Okay, now it's time to turn the tubes, and it's gonna be quite tricky because I have to drill or bore all the way through it, and it's a very long way to bore, and it's a relatively small bore also. So I'm first gonna bore from one end and then flip it and turn the other way around. And I actually did already the first one, and I used this Sandvik 32mm boring bar. But I think for this one I'm gonna use this one, which is a 40mm bar. So it's quite a bit larger, but it is also shorter, so I can only support it by 3 screws, while this one is supported with 4, but I will have to see how it does. Because this tool was actually working pretty well, but it was producing an awful amount of chatter and noise. But it actually did the trick. And what I'm gonna start with is getting this piece centered. And when that's done, I'm gonna actually first remove the steady rest, and then I'm gonna turn this all the way just to clean it, and then I'm gonna use the steady rest and start boring the inside of the bore. So now let me get the mag base for the camera, and let's start indicating. Okay, now you should see both indicators. I hope the focus is good enough. So I'm gonna start from this end, which is closer to the chuck, and when it's close enough, then I'm gonna use copper hammer to tap the other end straight. So let's start indicating. Looks pretty good to start with. It's very close actually. Okay, that's as close as I can get this side. It's within 20 hundredths. So, how I like to center this stuff that's not completely round. This one is between 70 and 80, and flip 180 degrees, and this is between 70 and 80, and 90 degrees. This is 60 and 70, 180 degrees. And this is about 70, so one more tightening here. Okay, that's as good as I want it to be. Now let's check the further end. Right here. It's about within half a millimeter. And actually I think this is how I'm gonna leave it. Well, maybe just a little bit. Not sure if it's any better. The chuck is so tight that it's not moving much. And I don't want to hit any harder than this. So, I'm happy with this. Now let's remove the indicators. If that's possible, they are stuck to one another. They're actually on. Very tight. Extremely tight. Okay, I got them off. Maybe that's not a good idea to do. Those indicators are supposed to hold 80 kilograms or 800 newtons. Okay, now I'm gonna remove the steady rest, which I don't like very much because it's extremely heavy. And I got a nice little wrench for it, 36 millimeter. Okay, doing the cleaning cut with this insert, so I can use some fast feeds, and also I'm using this insert edge because it's already worn, and I know the stuff on the shaft is very abrasive. And the feed is pretty high. I think it's 4/10 per revolution. Four-tenths of a millimeter. Let's move the camera back and zoom. dust on my camera. Taken off 1 millimeter. Okay, it is actually cleaning all the way around. I guess let's take just a little bit more. Okay, now we can go all the way to the end. Slow speed and fast speed for reduced vibrations. Surface finish is far from good, but that's okay. Trying to protect the waist and the crosslight with some rags. I'm getting a little bit of vibration, but that's okay. Okay, I think this is enough. Okay, doing another kind of a finishing pass for loops and also for making the steady rest's life a little bit easier, because the steady rest does not have ball bearings. It only has some cast iron, at least I think it's cast iron, and pads, wear pads. So the smoother the surface, the better. Okay, the steady rest is now set up, and the very first thing I like to do is give it some oil. Something like that. And now I'm gonna start bringing in the supports. Okay, that should be good. first thing to do is to make a little bit of a relief for these pieces, one for each end. So this one needs to register from here to here. So I'm just making a short relief, 5 millimeters long. RPM. Looks like the support is doing a pretty good job. So I need 85 millimeters, so almost 10 millimeters to go. Two and a half per side. At all. .7. Let's try 1.5. Almost there. That should do it. Yeah, really good. It's just to help when welding. Okay, now let's get to the heavy turning. Okay, now all set for the boring work, and I have the large boring bar set up. And it's got a fresh insert edge. So let's see how it does. I might have to change the center height. let's see how it does. I have no idea. It's actually doing very well. A whole lot better than the smaller boring board. This one is also flexing. And you can also see it flexing, but that's mostly because the inside, I mean the board is not round. So the load on the boring board is not consistent. It's actually making great chips. I'll just have to watch if it will clear on the backside. I think it will. Yes, it will clear. Let's see what the finish looks like. The finish is not terrible, but not good either. And that's most probably because of the flexing. And it's, as you can see, it's leaving quite a mark right there when it's exiting the board. So that tells about the board flexing. But I think this is how I'm gonna go for a while. And I'm first gonna use this much stick out, and when I run out of stick out right here, I'm gonna extend the board a little bit more. But I'm gonna do the first cuts with this shorter stick out, so it's a little bit easier first. Okay, I think this is how I'm gonna do. Let's increase the depth of cut still a little bit, and then just go. And this is 1 mm per side compared to the last cut. And the speed is pretty slow. It's 180 RPM, just to avoid vibration. And I think I'm gonna keep it so. I'm not gonna show you a whole lot about this, because this is a boring operation. Let's see what happens when it enters the deeper cut again. It is flexing, but actually no chatter at all, which is really good. So, this is how I'm gonna go for a while. I'll get back to you. Okay, the first cut is finished, and it's actually making pretty nice chips. So now for the second pass, which is also the final pass, the diameter will be 62 millimeters. And right now I am removing 3 millimeters per side and 6 millimeters of diameter. So it's a little bit heavier this time. I can try to show you what kind of a chip it makes. RPM and feed is 0.16 millimeters per revolution. Let's go. This is a nice cut. A little chip bin in here. Sometimes some chips come out of the board, the spindle board.